Okay, so we're going to kind of make a start now. I think some more people are coming a bit later because there was like a test on for analog electronics. But the first part is mainly going to be trying to get C++ running on your machines so everyone is able to actually code and submit solutions. So first thing is, I hope everyone either has, they're all computers here which you can use, or your laptops. So I did send out instructions for like running C and C++ on your own machines. For anyone who hasn't seen them, I'd recommend using the uni computers, but the way you have to load them up is kind of different because you don't want to use Windows, you want to use Linux. So, actually, can everyone raise their hand if they know like how to get C, if they've already gotten C or C++ running on their machine? Nice. All right, everyone else, I'd recommend like making sure you're at a computer and restarting it, and it'll come up with a boot menu, and you want to choose the Linux option, not Windows. Can I get the committee to help out with anyone who's having issues with that?
Yeah, that's fine.
Yeah, so if everyone wants to get that ready now. And also there's some sample code here. You can try writing that and see if it compiles. You can just use these two commands. So we'll probably, while more people rock up as well, we'll give probably about 10 minutes to try and get everyone to do that. Feel free to raise your hand if you need any help with that. Okay. All right, I think almost everyone's got C++ compiling, which is good. So I'll just go through what's on the slides quickly. So there's sample code for Hello World, if anyone hasn't copied that down already. There's a few different ways you can compile it. There's a bunch of different options for compiling C++. So this is like the very basic method, which is just bare bones if you want to do something quickly. You can also give your output file a name using the -o flag. So if you want to name the executable that the compiler results in. What I would recommend for competitive programming is these flags. So what this basically means is you've got std equals C++20. That's the version essentially. So C++20 is one of the more modern ones. And so that gives you access to newer features that are sometimes helpful in competitive programming. -wall basically stands for warn all, and it'll give you a bunch of compiler warnings if there's a chance that your code has any errors, and then giving it a name, which I don't usually do, but you can if you like. So that's the best way. Doing it locally is probably the fastest way, which is important during competitions. You can also compile online, which is a good way to test stuff quickly, but I'd recommend not using that just because it's a bit of a pain at times. So I think everyone's pretty much got it working locally, and people who don't are getting help right now, so I'll move on. So what does actually all this mean, the boilerplate in the Hello World sample? So there's a few things here. It's a lot more complicated than something like Python, which you guys might have used before, or MATLAB if you're doing MATLAB and C. So first of all, we have to include this IO stream header, which basically is because C and C++ are very basic, or bare bones languages that are designed to not have any more like any extras that they don't need to keep it very lightweight. So you can do stuff like systems programming. IO stream basically is it's called a header file, which basically includes stuff from the standard library relating to input and output. So very important for competitive programming. In this case, it includes this standard cout and standard endl. So standard is just a prefix, meaning it's from the standard library. Cout essentially represents the output terminal of your computer, and so that's where if you want to print anything out to the terminal, you need to send your variables, whatever you're printing, to cout, which is done with this arrow operator, which is a bit of a weird syntax, but something you just get used to. Hello world's just your string, and then endl is a new line character, as well as it flushes the output buffer, which basically means it prints all the output immediately, whereas if you don't have that, there's a bit of a delay. And so this is kind of important. So this is actually what we'd see more often in competitive programming compared to this one. This is what you might see more in like industry or standard code. The first one is this include bit/stdc++.h. So this is a bit of a trick that we use in competitive programming, which is a header that's in the G++ compiler. It basically includes the entire standard library. So rather than worrying about this like IO stream, any like, if we want to use certain features or data structures, we might have to include the relevant headers. Rather than worrying about that, you can just include this and forget about it. It'll include everything. So not a great idea in like industry code, but very helpful in competitive programming. The one issue with this is that because it is specific to G++ compiler, the default one on macOS, which is Clang, doesn't actually include it. There are workarounds to this. You can like download this file and basically include it manually, and I'll include some structures on the Discord afterwards about how you can do that if you want to code off your Mac computer during the competition. But what I do is I have a Mac laptop. I just use the university computers because it's easier just to do it off Linux. Next is this using namespace std. So that basically means you don't have to type out this std for anything that you've got from the standard library. Again, it just makes it easier to type out, do it faster, less likely to make mistakes. Not something that's a good idea in industry for reasons I won't go into, but it's just basically a quick speed up that you can use during competitions. So then we get rid of the std here because we've got that using namespace. And then rather than endl, you can also use \n for a new line, which is just, it's slightly faster and quicker to type out as well. Does anyone have any questions about any of that? Cool. Okay, so data types. So I'm assuming most of you here are first years who are probably doing MATLAB and C right now. So currently you'd be in the MATLAB phase, which is similar to Python, in which all the variables don't have data types. You can basically assign whatever you want to a variable and change it throughout the running of the program. C and C++ are a bit different, where when you declare a variable, you have to give it a specified data type, which can't change during the duration of the program. So an example is like this string is the data type. The data type comes before your variable name. And so string, you would have done strings in MATLAB, is basically just a sequence of characters. But that means that you can never change the type of this variable. So my string will always contain a sequence of characters, like a string. You can change that during the runtime, but you can't change the type. So you wouldn't be able to assign it like an integer value. String is a bit different to these other data types. So that's because string is included from the standard library. So that's another thing where using these two lines up the top, it makes it a bit quicker to write out. You don't have to include the relevant header files or use std in the prefix beforehand. The rest of these, which are all color-coded by VS Code, are all built-in data types into very basic C and C++. These are all essentially different number types, but there's a few minor differences between them. The first three are all for integers. So int is kind of your standard integer. That's what you'll see most of the time, and contains values up to, it depends on the hardware, but usually a 32-bit integer. So numbers between negative 10 to the 9 up to about 10 to the 9. So you won't need much else ordinarily. If you do need longer or larger integers, there's long, which has double the number of bits. So it essentially allows you to store a lot more if you need to have large numbers, which is important in some problems. Usually you'll see in the question description if you need, if you might need to address numbers larger than about 10 to the 9. Char is usually used for representing characters, like the letter A, but underneath this is just the ASCII value. So A is I think 70 something. If you have an ASCII table, you can convert between them, but it's basically an underlying integer, but usually used to represent characters. And then floats and doubles represent decimal numbers, where doubles essentially have double the precision, so almost always in competitive programming you just default to a double instead of a float. Another thing that I've got here is this int max, which basically represents the largest integer, or the largest number that can be stored in an integer variable. Which is helpful for if you use Python, you might use INF for infinity, if you want to represent the largest possible number. That's one way that you can do it in C++ if you want to have a starting value that's very big and then maybe minimize it over a series of processes. So I've got an interactive thing here. So there's an error in this section of code. So I've got two integers, x and y, set to 10 and 3. I want to find the quotient of them. So I've specified double here because I want this to be a decimal number. It should be about 3.333, etc. This won't actually print out 3.3333. It's going to print out just 3. Does anyone have any ideas as to why that might be? Yes? Format? Did you say format of it?
Yeah.
So not quite. So unlike C, which has format specifiers, C++, because this quotient is a double type, it will print out all the decimal places by default. So it's not the format that's an issue, it's something else. Isaac?
Dividing an integer by an integer?
Yeah. So because we've declared x and y to both be integers, even though this result is a double, when we divide an integer by an integer, the compiler automatically essentially makes this result an integer before assigning it to the double. And the way C++ does this is it just gets rid of whatever's after the decimal place, it just truncates it. So you've got 10 divided by 3, which is 3 and a bit. It sees that these numbers are both integers, so it says the result must be an integer, and sets it to 3, which then assigns it to quotient. So there's a few ways you can fix this. The first is you could just assign x and y to be doubles instead of integers. That'll fix that issue. Alternatively, you can do something like this, where you put the type you want in brackets before the variable, which is known as a C-style cast, and basically force converts it to be that type. So we're forcing x and y to be considered as doubles here instead of integers. So then we're dividing two doubles, results are double, and will give us the correct answer of 3.33333. So more on data type conversion. So I've got another example here where I've got a string that's represents a number and an integer that I want to convert to a string. So I want to basically swap the data types, if that makes sense. So I want my string, I want to convert that to the integer number 90 here, and I want to convert this integer number to a string. These casts won't work. Does anyone have any idea why?
Because you'll assign the first one and then we'll go to the second one and try and assign the same data?
Not quite. So these are different variables that I've given different names, so that won't be the issue.
Oh, they have to send.
Yeah, that's all good. This is quite a tough one, but so I mentioned earlier that string isn't a built-in data type. It's provided by the standard library in like this header. And so because of that, whoever coded up that standard library, they didn't include this C-style cast. This isn't a function that's supported by strings because it's not a basic data type. So instead, for whatever reason, they decided to give different functions to it, which have arbitrary names essentially. It's kind of hard to know them. If you don't know them already, you're not going to figure it out by guessing. But there are functions in the standard library that allow converting two strings and from integers to strings. And so whenever you don't know something, a good idea is to try finding it on this website. So this cppreference.com is basically the most commonly used website for finding C++ functions or syntax or anything you want to check. These are allowed access during competitions. Even like at the very top level, you always have access to this website. So it's very good to get used to. So what I'd like everyone to do is to try going onto this website and searching for functions that will let you do these operations of converting between integers and strings. So have a go at that, and feel free to raise your hand if you're having any questions. Yes, Ramisa?
To typecast into this new variable called string that is not recognized by the compiler, can we just create a class called string and then have some specifications like variable assigned to it, and then we'll be able to pass it into this called object here?
Can you explain that a bit more?
I say that with this string that's smaller, it's not defined by the C++ library, right?
Yeah.
So that's why we cannot create a typecast into string.
Yeah.
So what we can you do? I'm not familiar with C++ what Java is, what Java is like. If you want to typecast into a certain class that doesn't exist or cannot be understood by the programming language in Java, we create a class by that name, and then we assign some variables to it, like public variables to it, and then we can create multiple classes and then we do typecast.
I think that might work, but there's an easier way to do it. So the main thing is just this specific type of task isn't defined by the standard library, but there are different functions that essentially give us
Yeah, I've never even used it.
those functions are.
That's like fast. That's how you do it. C++.
Yeah. So that class takes you all the time out.
Is that what it is? Just like typing optimization?
Like that's how I do it with the faster type and stuff.
Where you put up, you would use static.
If you're doing like industry code, you I mean, ideally you would use it all, you find a way with broadcasting. How's everyone going? Has anyone managed to find the functions you need? Not yet? Yeah, so there's a search at the top right. So if you search by some of those strings here. Two string, yeah. So sorry, what's your name? Roy. So Roy's figured out the first one. So if we want to convert, or no, that's the second one. No, first one, yes. If you want to convert an integer value to a string, you can use this function toString, which basically takes in any number and will return a string. Revealed kind of the other one here is S2I, stands for string to integer, which does it in reverse. So if anyone wasn't able to find that, I'll quickly go through that here. Yep. Up top. There we go.
You should probably use the mic because people are starting to just talk and stuff.
Yeah, maybe. Get this way. Okay. Hannah? Shahid, how do I get rid of this? Is that-
I have no idea. Honestly, I don't know. Sorry.
Oh, there we go. Okay. Okay, yeah, that's better. So for anyone who wasn't able to find that, if you wanted, so I'll do the second one, for example, if you want to convert a string to an integer, if you search up just something like string to integer, then the first result that comes up is this one, so s to I. And just an example of, this has got a lot of information here, so it can be a bit overwhelming at times. But the main things you want to look at are first you've got all of these different function signatures, which basically, some are different, which is basically for longs and longs. So you've got your return types here and what you have to pass in. So if we look at kind of what parameters it takes, we can scroll down here. So first is the string to convert, which is what we did. We just had the basic, passed in the string and nothing else. There are also this pos and base, which are optional parameters. They default to null pointer and 10. And if we check here, it says basically there's the address to store the number of characters processed in. We don't care about how many are processed in this case, and we're just using base 10, so we don't need to change those. And it returns the integer value that we want. And there's also usually examples on most pages here, so we can see an example of how it might be used, like in this case. It's a bit hard to do this looking at a different screen, but yeah, where that's just some number that's instead quoted. Cool, does anyone have any questions about this so far? No? Okay, we'll move on. So input and output. So we've already seen some basic output using cout. For input, we've got, actually before we get to that, for output, like I mentioned before, there might be like the format output for floats or doubles. Sometimes we want to output a specific number of decimal places, which is a mistake I've had quite a few times where I've gotten the wrong answer because I put out too many decimal places. The way you can do that is with this set precision, which basically sets the significant figures. So we can see here that this is outputting the 4 significant figures in that case by basically doing this set precision before doing the output, or doing the decimal number. For input, it's similar to the cout, but instead of cout we have cin, which makes sense. And then the arrows are in the other direction because you're kind of taking it out of cin and putting it into a variable instead of taking some variable or string or whatever and putting it into cout. So first you have to define your variables still. So define 2 strings and then reading first into string 1 and then into string 2. Doing the same with integers here. So you can also do it, just chain it in a row, which is a bit more compact and faster to type out. And then I'm just printing these out just so you can see the results here. So this is the input I tested it on with first string, second string, and then these numbers. So one other thing to note is that basically the way it splits it up is just with any white space. So that can be a space like here, it could be a new line like after second string. Either way works. So even though these are on different lines, the integers are still read in straight after each other like this. And you can see that they're correctly read in and read out. One other thing which is very helpful, so this is one thing you should definitely take note of for the competitions, you'll find it very helpful, is once you've got your compiled program, so a.out, I didn't give it a name in this case, if you define some file, such as like I would call it input.txt, you can use this left arrow, the less than sign, and the name of your text file, and that basically sends all that as input directly to the program. So usually in competition questions, you'll be given a set of example inputs and outputs. It can be very it's a lot of manual work and takes a lot of time if you want to test all those manually. A much better way to do it is to just have a file like this which you can copy and paste the input into, and then you just run it like that, and so you don't have to worry about typing any of the input in, and you can just see if the output matches what it should be. Any questions about that? Cool, and I think we've got some new people coming after the analog and /electronics test, so we can help them set up if they don't have C++. Ready to go. Cool, so operators. So most of these hopefully should be self-explanatory, especially with everyone doing MATLAB. I think you would have gone through most of these previously. So string concatenation, you can add them together. You'll basically just put the 2 strings together without any spaces. You need to add them manually. You've got all your basic math stuff, including the modulus, which does the remainder, which I think you probably would have seen in MATLAB. You've got your, instead of, unlike MATLAB, where I think the Boolean operators, you just type in like or and. In C and C++, you use like this to double pipe operator or double ampersand for or and. And then we've got some bitwise operators. Don't worry about these too much for now. I'll explain them in a moment, but does everyone want to quickly go through and figure out what the result of each of these operators are? And I'm going to print them out in a moment, just to compare. But yeah, so have a go at figuring out what these will be equal to. And also, if you know what the bitwise operators are, then you've probably done the other ones by now, so have a go at figuring out what they would be. And I'll explain them after briefly, but don't worry if you don't know what they are, they're more of an advanced concept.
Let me ask you something, right? So when you define something like this, can you use the same error focus? You can't, okay. Just gotta make sure.
Okay, does anyone else want some more time to think about it, or is everyone happy for me to move on? Take that as a happy to move on. So hopefully all of you guys got this. So we've got, this, for the string concatenation, it just like puts them together essentially, x first and then y. For all your maths, is what you expect, 13, 5, 15. The only one that you might not have been familiar with is this modulo, which does the remainder. So 28 divided by 5 is 5 with the remainder of 3, and so this gives you what that remainder is. Or, because one of them's true, it gives you true. In this case, it outputs as binary, is something to take note of. And they're not both true, so it's false. For these bitwise ones, the comments there are a bit of a hint. Basically put 5 and 3 in their binary representations. What the bitwise operators do is they essentially compare each of the bits one at a time in their place values. So it compares the least significant bits, and then the next one's over, and the next one's over. And basically does that logical operation on each of the pairs of bits individually. So in bitwise OR, you've got 1, 0, 0 and 1, 1 and 1. So all of those individual bits would be true if you compare them individually. And so that gives you the binary number 1, 1, 1, which corresponds to 7. So this is something that comes up, it's much more of an advanced concept, but I put in there as a bit of an extension for anyone who wants to look into that. And because you get the zeros in the first two spots in each of the numbers, so then this would be 0, 0, 1, which is 1. XOR stands for exclusive OR, so it's true if either one or the other is true. So in this case, you'd get 1, 1, 0 if you compare those numbers, which is 6. And for NOT, that flips all the bits. Because this uses something called two's complement representation for binary, I won't go into it, you can research it afterwards if you're interested. But it basically flips a bit all the way to the left here, so you think about this as having a bunch of zeros in front, and it flips a bit, that converts it to a negative number, which is why you get -6. What takes a bit of time to explain that, so feel free to look into that yourself. You won't need that for any of the beginner competitions, so don't do worry too much. Okay, so now I've got some practice. So I'd like everyone to have a go at writing some code that reads in 3 integers, x, y, and z, and then computes the following value. I've got the formula up here. I've given an example that you can test your code with quickly. So everyone have a go at that. Mainly in bit manipulation stuff. So low. Alright, I think most people have finished that, so I'll move on to the next slide. Or actually first I'll just go through my solution. So I just declared 3 integers, read them all in one line, just type out the formula. It's all integer operations, so you can just use an integer, and then print it out.
Is that the same thing? It doesn't accept the...
Before I move on, does anyone have any questions about that? No? Cool. Okay, so control flow. So similar to MATLAB, sometimes you'll want to do things depending on different conditions. So the main thing you'd use is if and else statements, if, else, and else if. So in this case, I've just got a simple example where I'm reading in an integer x. If it's bigger than 10, I'm printing that out. If it's not bigger than 10, but it is greater than or equal to 0, so because of that else if, then I'm saying that. Else, it must be less than 0, so printing that. Any questions about that? No? One thing to also note in C++ is that you need these curly braces. White space doesn't matter if you're used to like Python, but you do need, or if it's one line, you don't need the braces, but if you want more than one line, you need these, and the condition always has to be inside parentheses, unlike Python, which you don't need the brackets there if they're not necessary. So we've got an exercise for that. So try writing some code that will read in one integer and one string in that order. And if both the integer is even and the length of the string is even, then print yes, otherwise print no. Okay, I think everyone's pretty much done there, so I'll go through my solution. So I've got my integer and string, which I did just define as x and y, reading in that order, first the integer, then the string. So back using the modulo operator, so if the remainder when you divide by 2 is 0, that means it's evenly divisible by 2, so it's even. And then checking that as well as, so that boolean and operator. Y.size, you can also use y.length, which hopefully some of you guys managed to find on the CPP reference. But checking if that is also even. If both are true, printing yes, otherwise printing no. Okay, loops. So these are pretty similar to what you'd get in other languages like MATLAB. So the main two types are for loops and while loops. For loops are a bit different. The syntax is quite different from MATLAB or Python if you've used those before. But basically, you've got these three different segments separated by semicolons. The first one is some code that's executed before the start of the loop. So in this case, I'm initializing an iterator to 0. The next is a condition that basically is for when the loop terminates. So while I is less than x, it'll keep running. After that, it's going to stop. And the last bit runs after each iteration. So it's going to increment I by 1 each time. This I++ is a shorthand for like I plus equals 1, if you're used to that in MATLAB or Python. So this loop is just going to loop through I, printing out all the numbers, going up to x, which is some number I've read in. I've got another for loop here, like illustrating like the versatility of these different statements. So starting I at 5 this time and going down by 2 at a time, while it's still greater than 0, or while it's positive essentially. And then I've got an example of a while loop here, where I've defined I outside the loop, starting at 1, and I've got this condition. While this is true, this will keep looping, and it's going to multiply I by 2 each time, until this is true, then it breaks. So just as a bit of practice, I'd like everyone to have a go at figuring out what the output of this program is going to be. So there's 3 loops, Matt putting different stuff for each one. See if you can figure out what that total output would be.
What are you reading in as x?
X, and let's go, I think it was 4, but don't worry too much about what x will be, more so the last 2. Okay, I think that's plenty of time just to look through what you think the output will be. So I've usually, that's just me typing in 4 as the input. So x is equal to 4 in this case. The first loop starts at 0, goes up 1 at a time, up to 3. After 3, it'll add 1, it'll get to 4, no longer less than 4, so it stops there. Next loop starts at 5, goes down 2 at a time. The next iteration will be -1, which is not greater than or equal to 0, so it stops there, doesn't end up printing this. The while loop starts at 1, prints, doubles, prints, etc. Once you get to 4, so that's this print statement here, it's going to double again, so I is now 8. 8 times 2 minus 1 is 15, so this breaks and we're done. Any questions? I've also got an example here. Write code that will keep reading the strings and printing them until it reads the string stop. Do not print this last string.
It's more.
Have a quick go at that.
Which is generally quite fast. So should I
You could pick up Python easily.
Alright, I think most people are finishing up. Is everyone happy if I go through my solution? Yeah. Alright, so there are kind of 2 main ways you can do this. Guys. There are two main ways you can do this. The first is what I've seen some people doing, which works fine as long as you get it correct, which is having like an infinite while true loop and then breaking out of it once your string is stopped. I did it this way, where I'm declaring the string first and reading into it, and then while that string is not equal to stop, I'm printing it and then reading in a new string. And so then eventually, once it reads in stop, it's going to break out of this loop without printing it.
Cross brackets and then brackets.
Any questions? Cool. Functions and parameters. Okay, so functions in C++. I'm assuming everyone here is probably familiar with functions in general already, so it's just their syntax we're kind of going through here. There's one key difference from like languages like Python or MATLAB compared to C++, which is the initial parameters or arguments. You've got different types that you can pass in. So as well as specifying the type, guys can quiet down a bit. There are these like additions you can add to the type. So I've got an ampersand here, which is a reference. So the other one is pointers. Don't worry too much about pointers for competitive programming. But the main difference here is that if you don't have a reference, this is going to basically create a copy of whatever value you pass in. This one is a reference to the variable, so it's going to be the actual same variable that you're passing in. So both of these functions that add one to x and then return it, which is kind of self-explanatory. But in my main function, so I'm defining x as 5. Y is obviously going to be equal to 6. We add 1 to x, so we pass in 5, add 1, get back 6. Which makes sense. But in this case, add one alternative, because that's taking in a reference to x, when it adds 1 here, it's actually adding it to that original variable. So in this first case, we'll get x and y 5 and 6, as you'd expect. This one's a bit trickier, because both x and y are going to be equal to 6, because of that reference. It's a bit of a tricky concept if you haven't seen it before, but does that make sense to everyone? So that's the output there, because this x, in the first function, this x is just a copy of this one. But in the second one, it's a reference, it's actually the exact same variable as this x. So when you're adding x to 1 here, or adding 1 to x here, it actually adds it to this variable. Does that all make sense to everyone? Cool, so I've got a question. To write a function that takes in a string and modifies the original string. So I don't want you to return a string, I want it to modify the string that's passed into it, so that it repeats itself twice. So for example, if the string is cat, I would like it to be cat cat after you call the function.
Did you just say that the variables like aren't labeled yet, right, in the function?
And also one other thing that I didn't mention, so in all functions you need to make sure to include the types of all your parameters and the return type. In this case the function doesn't need to return anything, so a return type of nothing is void. So you can put void as your return type for your function. Alright guys, can everyone quiet down? I'm going to go through the next one just because I do want to wrap it up soon. My solution, so here we've got, this is my function. So basically, void means it's not returning anything. The function signature is taking in a string reference, so that means it's referring to that original string, and we'll modify the original string rather than returning a new one. And then s equals s plus s. And so, because this has got this ampersand, it's going to modify that original string that you pass in rather than creating a new one. Any questions about that? Cool. Okay. Last thing before we kind of wrap up is DIV vector. So this is a container. So the standard library has a lot of data structures, which are very helpful for various problems. We'll start introducing those in future weeks, but for now, this is the most basic one, I guess. So DIV vector is basically like a sequence of anything. So in Python, you've got a list. In MATLAB, I think you just got arrays. In C++, you've got vectors. So vectors, because C++ is a type language, you have to specify what type is going to be stored inside the vector. So in this case, we're actually down here, we go to the main function. We've got vector, then these angle brackets, and int. So int is the type that's going to be stored in the vector. You can only have one type. Can everyone be a big one, please? So you can also have a vector of any type you want. You can have a vector of strings. You can have a vector of your own custom classes if you want. You just need to put that type in here. And then if you look on CPP reference, there's a bunch of functions you can use with vectors, but here are some basic ones. So I've got a for loop that'll go from 0 up to 2, and push back just basically adds it to the end of the vector. So this is going to store a list of like 3 numbers. I've defined these 2 functions to print a vector. I think they should both print the exact same thing. They're just using 2 different types of for loops. The first one is this int I colon and then the vector variable. This basically is like a for each loop, if you're familiar with Python, or similar to I think MATLAB's for loops, where it's going to set I equal to every element in the vector and then just printing it out directly. This one I'm going from the index starting at 0 up to the total length of the vector and then printing out the element at that particular index. So both of these will do the same thing. There's 2 different ways of doing it. So then I'm printing out this one, and this is an example of a vector constructor. So this default vector is just going to be empty when you create it. This one is, you can find this in CPP reference, is a certain arguments you can pass in when defining the vector, which basically says you want it to be of length 5 and fill it with a default element value of 3. So this is going to have 5 elements all set to 3. So if we look at the output, the first one I'm going from 0 up to 2 and pushing it to the end of the vector, so we get that when we print it. This one we got 5 3s because I said length of 5 with a default element of 3. Then example for this one, or practice for this one, is to write some code that reads in an integer n. This tells you how many integers come next, and then there's, on the next line, you need to read in like n space separated integers and store them all in a vector. So have a go at that. So Isaac has asked a good question on the last slide. So one thing you notice is that in both of these print vector functions, I've taken the vector using a reference, using that ampersand. In this case, it'll have the exact same functionality whether you have that there or not, but the reason I did this is because it's going to be a lot faster. So if you remember, I mentioned that if you don't have the ampersand, it basically creates a copy of the variable, whereas if you have the ampersand, it just is a reference to the same variable that you pass in. So if you're creating a copy of a vector, if you imagine a vector that contains 1,000 numbers, creating a copy of that will take a bit of time. Whereas if you just pass in a reference, it's not going to create any copy, it's just going to look at the original vector and essentially read memory from there. And so we'll get to kind of time complexity in a future workshop, but for anyone who knows what time complexity is, this could be considered, apart from all you're reading through anyways, it's going to be like O of n, but this actually copying it over will be like instantaneous rather than having to copy over every single element inside the vector. You done? Alright.
I have done this.
That's fine. I need to do this announcement anyway. So. Okay. Can everyone pause from writing their functions for a moment? Just because we are getting a bit late, I'm going to skip ahead here. I'll give you time to come back to this one in a second. But for the people who finished already, just so you're not sitting around doing nothing, there are some practice problems we've got. So on the competition website, which is AUCPL.com, if you haven't already, you'll need an account for the competition on Saturday. And Maggot has told me that some people have signed up but haven't got an account yet. So please go to AUCPL.com and register for an account with the username you put in your Google form. You can clear up any details of that later if you need, but just make sure you've got an account. Once you've got an account, if you go to problems, you'll find 2 problems that I've put on as examples, algorithm performance 1 and algorithm performance 2. And if you can have a go at that. Then also you can use this URL to get to that problem if you'd like as well. So yeah, the community will be around to help out. with you actually submitting on the competition website. So I'd strongly recommend trying to do this so you're ready to go for Saturday. If you've done the vector question, then you can have a go at those two problems. Otherwise, you can keep working on the vector one for now, but do make sure you've got an account registered on AUCPL.com. Alright guys, the laptop's about to die, so I'll quickly run through my solution for this, and the two solutions for the problems that are on AUCPL.com as examples, I'll leave for you to have a look at on the slides, which we'll post on Discord later. So for this one, I'll get my pointer out. So first I got int n, so reading in n, to figure out how many integers we need to read in. So that I'm defining a vector with this constructor here tells you how big you want it to be. So I'm saying create a vector with n elements of ints. Then I'm doing a for loop that goes up to n to read into each position in the vector from 0 up to n minus 1. And then I'm just testing it by printing out all the elements like this. We'll hang around a bit if anyone's got any more questions or wants to have a go at the problems on AUCPL.com. But then I've also got solutions that I won't show today, but you can have a look at on the slides later if you would like. Thank you everyone for coming. Also, please let us know on the Discord if you have any feedback. But yeah, and feel free to have some more food if you like.
Let's go to the CS club event. Alright, this is. Yeah.